Welcome. So we will continue our lectures on indoor air quality guidelines and control. In this lecture, we will look at indoor air quality control, for example, with respect to ventilation. So the air pollution mitigation strategies are needed to give an optimum indoor air quality. If we have some outdoor air pollutant sources, and we have some indoor air pollutant sources, all of these will then in a way lead to poor indoor air quality. So once we have achieved or once we have arrived at this poor indoor air quality, our goal is now to improve this air quality, which means we have to now adopt mitigation strategies. In terms of outdoors, what we can do? We can do source control. We can stop the emissions or reduce the emissions of what is outdoors. We can increase the air tightness of the buildings, meaning to allow less and less leakages through the buildings so that we have less pollution infiltrating indoors. We can work with the intake locations of air and control of those locations so that there is no active source or there is no source in those air intake locations. The air from where air is intaken and brought to indoor air, for example, through ducts. Then have filtration systems. So if there is a fan or a mechanical ventilation system, one can install filters so that the incoming air is is devoid or has less amount of the outdoor pollution coming inside. When it comes to indoor mitigation strategies, we can again do indoor source control. So, manage the sources of whatever can cause indoor air pollution and the sources indoors. One can increase the ventilation, especially if the outside air is cleaner. One can also devise recirculation strategies in which cleaner air or air is taken and cleaned and recirculated back, and filtration, which is common. When we have all these mitigation strategies, we can possibly lead to an overall optimum indoor air quality for the health and well-being of the inhabitant. So, what is the hierarchy of improvement measures? The most important hierarchy, the most important thing is removal of sources. On the right, on this side, we will see this decreasing preference. So the first preference is to actually remove the source. If the source is removed, there is no chance of pollution. The other is reduce the source emissions. So if the source cannot be reduced, then maybe reduce the intensity of emissions. Then the next priority is to disrupt the pathway of pollution. So somehow put mechanical filters, so that will disrupt the pathway, or some other means. Then the next stage is to protect the receptor. So to protect the human, maybe by wearing mask or personal protective gears. And the least preferred option is actually to remove the receptor. So the air is so polluted that you have to take the person out of the environment or out of the indoor environment. So naturally this is the least preference, because if the person is gone, then what? There is no question of indoor air pollution control. So this is the least preferred, removing the person from the indoor environment, and the best is removing the source to the indoor environment. So air filters are designed to help achieve some of this mitigation, and generally there is a minimum efficiency reporting value reported for different types of filters. What MERV is the ability to filter to capture large particles, generally of the range 0.3 to 10 micrometer. And once we have MERV value, we can use this value to compare different filters from different locations or different companies. but MERV value is sort of a standardizing reference from which we can compare these filters. So there are several, or actually many MERV ratings. Rating 1 to 4 means that the size 3 to 10 micrometer is reduced less than 20% by the filter. So this is the average particle size efficiency. So not much removal. MERV 5 means 3 to 10 micrometer particles are removed at greater or equal to 20% efficiency. MERV rating 6 means these particles are removed at a efficiency of greater than or equal to 35%. And MERV rating of 7 means these particles are removed at an efficiency greater or equal to 50%. MERV rating of 4 means 1 micron to 3 micron particles are removed at an efficiency more than equal to 20%, and the 3 to 10 size particles, 3 to 10 micrometer particles are removed at an efficiency greater than or equal to 20%. So from MERV rating 8 we also introduce the 1 to 3 micrometer size bin. MERV rating 5 means 1 to 3 microns particles are removed at efficiency greater or equal to 35%, and the 3 to 10 micrometer particles are removed at an efficiency greater than or equal to 75%. For MERV rating 10, we have 1 to 3 micron particles removed at efficiency greater or equal to 50%, and 3 to 10 micron particle at efficiency greater than equal to 80%. Once we reach MERV rating of 11, we are also now achieving removal of 0.3 to 1.0 micrometer particles at an efficiency greater than equal to 20%, 1 to 3 micron at greater than equal to 65%, and 3 to 10 micron at greater than equal to 85%. As we go from 11 to 12 to 13 to 14, these efficiencies keep on increasing. In fact, at MERV rating 14, 0.3 to 1 micron particles are already removed at an efficiency greater or equal to 75%. And 1 to 3 micron particles are removed at an efficiency greater or equal to 90%, and 3 to 10 micrometer particles at efficiency greater than or equal to 95%. So already very good removal is starting to be achieved. So for a MERV rating of 15, we have achieved efficiency of greater than equal to 85% for the size bin, 0.3 to 1 micron, and up to 95 for size bin 3 to 10 micron. When we arrive at MERV rating of 16, all the three size bins, the removal efficiency is more than or equal to 95%. Finally, we have the high efficiency particulate air filter or HEPA filter, HEPA filter, where all the three size bins are removed at an efficiency of more than 99.7%. So a very high efficiency of removal. Now there is some minimum efficiency reported value required for air cleaner filter. MERV 1 to 4 can be used in a common control containment in residential applications. For 5 to 8 MERV, we can probably contain mold, spores, dust mites, and animal dander. So we have a better residential, commercial, and office space. MERV 9 to 12 can remove certain bacteria, lead dust, some particles, humidifier dust, and can be used in hospitals, labs, and commercial spaces. MERV 13 to 16 can remove bacteria, droplet nuclei, cooking oil, smoke, insecticide dust, and is applicable to settings such as hospital and the surgery locations. Then MERV 17 not 10, MERV 17, which is the sort of highest. This should be like HEPA, for example. It can remove virus, dust of carbon and smoke, and can be used in electronics area where we have pharmaceutical, for example, medicine manufacturing, and in clean rooms. There are some minimum filter efficiencies required in healthcare facilities. For patient wards, MERV rating should be 14. For operating room, we should have MERV 16. For ICU, intensive care unit and infectious isolation room, MERV rating should be at least 14. And in a very protective isolation room, we should have MERV basically 17, which is high efficient. HEPA filter should be functioning very well. In lab, MERV rating 8 would be okay. In emergency rooms, trauma resuscitation rooms, MERV rating 14. In a place where we have like labor, delivery, recovery happening, MERV rating of 14. And the dialysis treatment area, MERV rating of 8. In autopsy room, MERV rating 8. In burn units, maybe more sensitive environment, so HEPA grade. In general examination room, it's not very, maybe 4, 5, something of the earlier could do, one of the earlier MERV ratings. And places such as laundry for the hospital environment, 8. The recommended airflow pattern in operating rooms is generally ceiling to floor. So if this is sort of the patient, the clean air should come to the patient and then go away like this, and rather not touch. So basically the person who is being operated on is exposed to the clean air. The particulate matter pre-filters with the minimum MERV rating should be placed upstream ahead of the cooling or heating coil, and then have a final filter. So if this is our airflow, first our pre-filter, the main pre-filter with the minimum MERV should already be placed, and here we can have our heating or cooling system, which is taking some air intake, air inflow, and giving the output to the room, and this is our final filter. So we should already have a pre-filter here and then final filter later. This is a sort of a complicated flow sheet of a occupied space and how the circulation and recirculation is happening. For example, we have the local air coming in and having local exhaust, local ventilation, and then is exhausted and exfiltered, and we have a air cleaner location here, so some air cleaning is happening. Then we have return air with air cleaning locations, again air cleaning, air conditioning unit, and then another air cleaning, and some recirculation can come and have an exhaust or an energy recovery, and again air cleaning and becomes air to the room. Sometimes some outdoor makeup air may also be needed to be given from another pathway and goes through several air cleaning operations. And then we have the overall exhaust here, and then exfiltration. So it's a very like circuitous system, and the air passes through cleaning mechanisms at different and several places. And the goal is to achieve a good MERV rating, a good indoor air quality in this occupied space. Okay, now how can we remove natural ventilation? By opening the doors and windows and vents where possible, and by avoiding closing doors or windows completely when people are in a naturally ventilated area. Then air rooms, basically refresh the room as frequently as possible, generally when the room is unoccupied. For mechanical ventilation, we should set the system in a way that maximizes fresh air coming in and avoids recirculation. We can extend the operating time of the ventilation, ensure extractor fans in toilets and bathrooms, but also ensure that these kind of fans are not recirculating air to other poor ventilated area of the place, because then this sort of recirculation unclean air goes to the other occupied area, and that's not advisable at all. So we have to ensure such fans are not recirculating air to other poorly ventilated area of the workplace. Also, a general guideline is to not lower the mechanical ventilation rate if the number of people in that area has reduced. We should maintain the ventilation even if there are fewer people. When temperature is a concern, one can open windows and doors fully to air spaces before and after occupancy. Even partially open doors and windows can provide decent ventilation to probably take care of temperature. Opening higher level windows maybe to create fewer draughts, and setting heating to maintain a comfortable temperature, but use fan convection heaters if the area is well ventilated only. Then we have to define some air intake minimum separation distance. When we have a significantly contaminated exhaust, the air intake distance at least should be 15 feet or 5 meters. When we have dangerous or noxious exhaust, this should be increased to 10 meters or 30 feet. And when we have vents, chimneys and flues from combustion applications and equipment, minimum distance should be 5 meters or 15 feet. This is minimum, so we can always increase the distance. When there is a garage entry or automobile loading area, the intake should be at least 5 meters or 15 feet away. If there is a cooling tower intake or basin, at least 5 meters or 15 feet away. For a cooling tower exhaust, 7.5 meters or 25 feet away. Then if we have occupancy categories, for example arenas, there should be a minimum exhaust rate. So for arenas it is 0.5 CFM per feet square. As we go from this to auto repair, we have 1.5, so we need more exhaust. Same if we have cells with toilets, then 1. So variable locations have variable exhaust rates prescribed. In dark rooms and labs and janitor closets, we need more exhaust rate compared to like local kitchens and the like copying and printing rooms. If you have a locker or dressing room, we only need 0.25 CFM per feet square. Pet shops generally need more. Laundry storage rooms for dirty laundry. Chemical storage rooms need quite a bit more of ventilation, especially the chemical storage rooms. Classrooms are a little bit lower. So how much ventilation is enough? We must supply enough air that is equal to all the air in the space. Basically, we have done this. How much air we have to change to completely change in the room. How many changing of the complete air in the room are needed per hour. Now, some of the recommendations says aim for 5 or more per hour, which will ensure a very good flushing of the indoor air with outdoor air. But of course, the outdoor air should be cleaner also. This type of flushing then helps to clean the air by reducing the number of, for example, germs in the air. There are some recommended values for ventilation rate in air changes per hour. For living rooms of buildings, residential buildings, it was 3 to 6, and for SARS-CoV, it was COVID-19 basically. This was increased a little bit to 4 to 7 air exchanges per hour. From bedrooms, 2 to 4 as per NBC, 2 to 4 air exchanges per hour, and 3 to 5 air exchanges per hour considering COVID-19 virus. For changing rooms and bathrooms, it used to be 6 to 12 air changes per hour, so of course much higher than living rooms or bedrooms, and even more high when considering COVID-19, almost 8 to 12 air exchanges per hour. That's a substantial amount. For corridors, 5 to 10 air exchanges per hour in 2016 and 6 to 12 for COVID-19 consideration. Entrance halls, 3 to 5 air exchanges per hour as per NBC 2016, increasing to 4 to 6 air exchanges per hour considering COVID-19. And for kitchen and gymnasium, which generally have a lot of indoor sources, 6 minimum air exchanges per hour are needed as per NBC code 2016, and at least 10 needed considering the COVID-19. This is same in garages, 6 to 8 as per NBC and 8 to 10 air exchanges per hour as considering COVID-19. For cellars and basements, our range is high considering the actual setting, 3 to 10 air exchanges or 4 to 12 air exchanges. The number of air exchanges required for laundries are much high, 10 to 30 air exchanges per hour as per NBC, 12 to 36 air exchanges per hour for COVID-19. Lavatories and toilets, 6 to 15 or 6 to 10, and 8 to 18 or 8 to 12 considering COVID-19. And in isolation quarantine rooms, at least 10 air exchanges per hour were needed for COVID-19 management. Then bakeries and dye works have even more, 20 to 30 air exchange per hour needed as per NBC, 24 to 36 for considering COVID-19, and then various other air exchanges per hour. Assembly rooms, banks 4 to 8, 8 to 10, billiard rooms and hospital wards 6 to 8 as per NBC 2016, and 10 to 12 for COVID-19 consideration. Then coffee bars, compressor rooms, studios, canteens, restaurants, dairies and conference rooms, 8 to 12 exchange per hour as per NBC 2016, and 10 to 15 air exchanges per hour considering COVID-19. Then churches, there were fewer as per NBC, 1 to 3 only for non-residential buildings. So now we are looking at non-residential areas also. And for COVID-19, the requirements were much higher, 10 to 5 air exchanges per hour. Higher values are needed for environments such as cinemas, theaters, hairdressing salon, photo and X-ray dark room, because these are confined spaces or places which is lot of like cutting happening, or places which are occupied a lot and also are confined. Same goes for public house bars, club rooms and dance halls, at least 12 or 15 air exchanges per hour. And in hospital, like sterilizing environment, 15 to 25 or 18 to 13 air exchanges per hour. And in the domestic section, 15 to 24. For labs, 6 to 15 air exchanges per hour as per NBC, and 8 to 18 considering COVID. For lecture theatres and libraries and offices, we are looking at range 3 to 10 air exchanges per hour for NBC and 12 minimum for COVID-19. And lift cars, 20 or to 24 air exchanges per hour or air changes per hour. Paint shops, very high values, much high air changes per hour are needed. Same for recording control rooms. And then shower baths also need more air changes per hour. Fewer values are needed for storehouse and warehouses and places such as squash courts, but high values are needed for utility rooms just because the setting is like that, 15 to 30 or 18 to 36 air changes per hour. So in summary, in this lecture we have seen that there are several guidelines to improve indoor air quality and with respect to ventilation. So this concludes this particular lecture.